All right. So I guess we are live right now. So let me check. Yeah, that's great. Right. So I hope my video is visible and my audio is audible to all of you. All right. So so I guess with this, we are back again today with another video, and that is useful for your CBSE board examinations. And today our topic is going to be integrals. All right. So today we will basically look into the concepts of integrals. Okay, so with this particular lecture, you will understand that we will be basically solving on different types of questions that are that has been asked in the previous year the CBSE board examinations, as well as your mock test, right, in different schools. Okay, so with this particular lecture, you will be at least getting some confidence on different types of questions that you can at least try to expect in your paper, right? So our topic is going to be integral. So it is not only limited to the questions of definite integrals or indefinite integrals, it will be a combination of both the topics. All right, so we have already made a series on, and we have already started with the applications of integral in the previous videos. So if you haven't watched that content, you can definitely watch that content on this particular channel. Okay, so before we start with the contents, I want to remind you again, please don't forget to like as well as subscribe to the channel. Okay, so we are basically trying to help you all of you people out so that you can prepare well for your examinations. Okay, so with this particular lecture, I hope we are able to help you out with your upcoming CBSE board examination preparations. Okay, so people who are basically watching this particular lecture will definitely will be able to make use of the entirely from this particular lecture, and I can guarantee you that if you are watching this currently and you are definitely solving the questions with me, I can assure you that at least you can do better in your maths examination. At least you can definitely try to score about 95 plus, right? So my name is Sirsha Banerjee. I will be the instructor for this particular course. All right, so let's start. So today we will basically discuss about some of the important topics of integrals from the CBSE for the perspective of CBSE 2025 paper. Okay, so along with that, we will also analyze different methods of solving integral problems. Okay, and I have come up with some shortcuts as well as with this particular problem. So maybe sometimes when you solve the questions from like MCQ types of questions, or where basically one marker questions, they definitely ask. So it is always essential to also have a shortcut with your preparation, right? So that will actually give you the answers quickly. Okay, along with that, after we solve the previous paper questions, we will also analyze that what are the different questions that you can expect to get in your 2025 paper. Okay, so with this, I wish you all good luck, and let's get started on this particular lecture. Okay, so before we start on with today's lecture on integral, I have got some important note before we start on to solve the questions. Okay, because after this, some of the few notes I wanted to talk about, because this is basically very important. Okay, now many times it is very confusing about students that I have seen, so have bought this particular concept to help you out. Okay, now this is basically useful for trigonometric integrals, which is basically an important part of an integral. Okay, so the important thing is over here, it will note that whenever you have any integral of this fashion, sine to the power mx and cos to the power nx dx, where m and n are both at natural numbers. So if you see that if your m is basically an odd, if your m is an odd number, then definitely put cos of x is equal to t. Okay, so if you get m as odd number, you just put cos of x equal to t. Okay, now this is all what I'm saying is all from my experience of solving questions. Okay, and I want that experience to be shared among all of you. Okay, so whenever you see trigonometric integrals and you have this m is an odd, so please put the cos x equal to t. And if the other way is around, so if you get n is equal to odd, then put sin x equal to t. Okay, now if you do this particular way, so you can definitely see that your questions or of an integral becomes very simple, and it get reduced to a simple form. Fine. Now it is also important to understand that if your both m and n are odd numbers, or you get an odd, then you just need to put sin x equals to t. Okay, now if both your m and n are odd, then just put sin x equals to t. So if your m is greater than n, if your m is greater than m, and cos x equal to t, otherwise. All right, so you just put sin x equal to t when your m is greater than n, and you, or if it is not the true, so for example, if m is not greater than n, then you just need to put cos x equal to t. I hope this particular thing is very simple and very clear, right? Now with this, I will also tell you that if both m and n are even numbers, then just use the power reducing formula. So if you have both m and n are even, then just use the power reducing formula. What is the power reducing formula? It is basically simple, that in cos of 2x can be easily written as I guess this color is visible, right? Otherwise I'll take a yellow color. Okay, so by multiple angle formula, so cos of 2x is basically equal to cos square x minus sine square x, right? So if you know this particular formula from your trigonometry, you are basically very good to proceed with the questions. Okay, so this part is clear, right? So from here you can definitely express sine square x equals to 1 minus cos 2x by 2. Also you can also represent cos square x as, so from here you can use a relation, that is sine square x plus cos square x equals 1 for all x real, right? So for all real number of x, you are basically having this part true, right? So if you just reassemble this in terms of cos square x or sine square x, you are going to get these two results, which are the power reducing formula, right? So this part is simple and clear enough, right? Now if you have m plus n as a negative even integer, if we have m plus n as a negative even integer, then just put tan x equals to t. That's simple it is. So whenever you have m plus n as a negative integer, you just need to put tan x equals to t. Okay, so if you just remember all this particular substitution, so then you are basically very good to go with the questions of substitution. Okay, so integration by substitution are very simple if you just try to remember this part. Okay, so this will actually help you in your preparations as well as solving questions. Okay, it is not only important for your JEE, not only important for your CBSE, but equally important for your JEE mains and other engineering examination you are basically appearing for. Okay, so with this particular note, let's move to the next note, and with this I have some of the important substitutions that you need to remember it. Okay, so some of the very crucial important substitutions I have written over here is that when you have any integrand of the form a square minus x square, the very important substitution that you need to think about is basically putting x is equal to a sine theta or x equals to a cos theta. That's it. That's how simple it is, right? And similarly, if you see the integrand of the form square root of x square plus a square or 1 upon square root of x square plus a square, you just need to put x equals to a tan theta or a cot theta. That's how it will be basically solved, right? Now please ignore this part, sine hyperbolic h, okay, because hyperbolic functions are not included for the part of syllabus, but I have got this just to show you the sake of completeness. Okay, now next thing is that if you have x square minus a square square root of that as an integrand, or 1 upon square root of x square minus a square, then you just need to substitute x as a sec theta or cosec theta. That's how the problem is simple, right? Now you must be wondering, like, why are we doing this substitution? What you will understand is that, so if you just use the substitution, you will see that in a square minus x square square root of it, so if I just put in place of x, if I just put a is equal to x is equal to a sine theta, then if I just put it, this will basically simplify to as a square minus a square sine square theta, right? And therefore this can be very simplified and written as a times of mod of sine theta. Okay, now I'm writing as mod because I don't know about the sine of theta, right? Or I don't know the range of the theta. Okay, so you can see that this basically simplifies just because of the trigonometric identities. Okay, so this is basically done just to simplify the trigonometric identities. Okay, now next substitution, if you see that if you have the integrand as square root of x by a plus x or reciprocal of that, or if you have square root of x into a plus x or 1 upon square root of x into a plus x, then your substitution will basically be of the form x equal to a tan square theta. Then your substitution will be simply of the form a tan square theta, right? And similarly, you can also, if you have instead of plus x, if you have minus of x anywhere over the same thing, you just need to substitute it as x equals to a sine square theta or a cos square theta. As simple as that. Fine. So this is just done for the sake of your calculation simpleness, and you just need to simplify this by the use of trigonometric identities. That's how simple it is, right? Now moving further, if we have a substitution like x by x minus a, now instead of a minus x, if you have x minus a, you just need to change it and put x equal to a sec square theta or a is equal to cos sec square theta. That's how simple, right? So these three sets and these three set are almost very similar, right? So if you can just try to understand, that difference is only in the power of x, right? So that is how we just need to replace and change, right? Now one more interesting substitution is that whenever you have a substitution like square root of a minus x divided by a plus x, or if you have square root of a plus x by a minus x, you just need to put x equals to a cos 2 theta, a cos of 2 theta. And similarly, now this is an important substitution, okay, not many people will know about it, but it is not that very important for your exam, but you can remember it. Even if any questions comes up in a J mains or J advanced, you can definitely solve those questions, right? So for the sake of completeness, I have written over here. So if you have square root of x minus alpha divided by beta minus x, or square root of x minus alpha into beta minus x, where beta is greater than alpha, then you just need to put x equals alpha cos square theta plus beta sin square theta. As simple as that. Okay, so if you just put this and substitute and use the integration by substitution, you're definitely going to get the results. Okay, so I hope by far whatever has been told is very simple and clear enough, right? If you have any query, you can definitely post that on the chats. Okay, I will be looking at your chats frequently. Okay, so please don't be if you're not getting anything, please definitely ask. Okay, it's not like that you cannot ask anything. You just definitely can ask everything in the live chat. Okay, I will be definitely monitoring that. Okay, all right, so by far I guess everything is good enough. So I believe you have understood whatever has been told so far, right? So with this, let's proceed for the very first problems. Okay, now first of all, I have a questions. Now you know that in CBSE examination you will have a collections of lot of questions. Okay, so let me brief about that part. Okay, so whenever you your CBSE math paper will be entirely made up of, so your paper will be actually made up of the following, right? You will have some 1 or 2 marks questions. Okay, they will be very short questions. Okay, then you can expect to get some 3 marks questions, and the bigger one will be like either 5 or 4 marks problems. Okay, so this is how you will be having a 80 marks paper. Okay, so I hope this is known to everyone, right? And your 20 marks is from the internal. Okay, that depends upon your assignments and your school projects, right? So this is something that you will actually face up in the actual exam, right? So very first we will basically start with the 1 marks questions. Okay, so short questions, and it is very simple. So if you just look at the question, so whenever this type of question comes up, now many students have a confusion like how to express or write the solution of it, right? So I tell that even if it is a question of 1 mark of formula, or even if you know the formula, please do not directly jump to write the answer. 1 or 2 lines of simplification will definitely ace the eyes of a examiner, and definitely will show you that you are a better candidate as compared to your other friends, right? So that will show that you are going to get a good marks better than other people, right? So this is something that you need to think about. Okay, so whenever you have a question, please write it mentioned as integral I. So you just mention this as let I be integral a to b f of x dx, right? And you need to express that in terms of a plus b minus x. So what do I do over here is that let me substitute. Okay, so I will write it over here. Let I substitute x as, or let us say I substitute t as, so I just wanted to substitute, so I substitute t as a plus b minus x. Okay, so I substitute t as a plus b minus x. So from here you will get dt is basically equal to dx, right? Therefore if you just write it over here by integration by substitution, okay, integration or integrating by substitution, we get your integral will basically change now. So this will basically become, so in place of x I will have a plus b minus t. So over here I will have a plus b minus t, and in place of dx I will have minus of dt, right? Now if you just put a into this particular equation of x, so you will get it as b over here as a lower limit, and the upper limit will be a, right? Now again, by using simple transformation of integral formula, that is integral a to b f of x dx is basically equal to minus of integral b to a f of x dx. Okay, very simple and simple property of integral. So if you use that, then I can just simplify this part, and I can write like integral a to b f of a plus b minus t dt, right? Now you know that in integral the variable doesn't matter unless and until you have this differential operator associated with that same variable, right? So therefore I can write this expression, same expression, as integral a to b f of a plus b minus x dx, right? So therefore you understand that this particular thing can be simplified to this particular formula, right? And we know this is a very important property of integrals, right? Definite integral. right? So if you just know this property, then definitely you can directly mark the answer. But I would always recommend to all of you, please do not directly mark the answer. Do 1 or 2 lines of steps of calculation, so that this is the way you are going to derive or come to this particular relation. Okay, that will definitely show you that you are a better candidate as compared to other people, right? So with this, you will have the answer as option number B. Okay, so that is going to be a right answer. Okay, so if you just mark option number B, maybe sometime, maybe in different examiner, you might also end up getting half marks. Okay, so you just have no way of losing any marks. So definitely write every steps and show the calculations. Okay, for getting the +1. Okay, so fairly simple. I hope this particular problem was simple and clear enough, right, to all of you. If you have any query, definitely keep me posted. Okay, all right, so I'm just looking at your chats. So I see, okay, fine, no one is having no issue. So I guess this particular question was clear enough and was clear, right? Okay, fine. So this question was fairly simple, and this is a very important property. Okay, so in questions of definite integral, we're going to be definitely using this particular property to solve or simplify our questions. Okay, with this, let's move to the next problem. Okay, now we have another question from your 2024 paper of your cbse examination. So let us see what this question has to offer. Right, so we have a indefinite integral over here. So let us say, now please refer to the way I'm actually solving or writing the answers. Okay, so this is the actual way you are going to actually do it in your actual examination. So whenever you are solving problems for your actual paper, please do not miss out on these small things. Okay, the way you express your answer, the more better you are basically seen in terms of the examiner, right? So therefore it is said that I is an integral given as x into square root of 1 plus 2x, right? That's what we have over here, and dx. Okay, now looking at this particular integral, now first of all, our first and foremost idea that definitely comes up to the mind is that we are not able to simplify. Okay, many students will definitely think of, right, putting this x inside the bracket and definitely go about, but I would say a better way to solve, not by using by parts, rather by using substitutions. Okay, so what will you do? Let us substitute over here 1 plus 2x as some variable t. Okay, let us say we substitute 1 plus 2x as t. So from here I will get 2 times of dx is equal to dt, right? As simple as that, right? So we'll have 2 times of dx is equal to dt from here. Therefore we can further simplify this integral. So again, you will write the same steps on substitution. Okay, we get the integral I is basically equal to integral. So in place of x, I will put it as, so from here I can simplify x as t minus 1 upon 2, right? T minus 1 upon 2. Okay, so let me clarify it and write it over here, t minus 1 upon 2, right? And 1 upon 2x is basically square root of t. So from here, now while you are assuming this is t, now you will understand that if you are assuming this is t, now this problem will again create a problem, because you are basically having some form like t minus 1 by 2 into square root of t, right? So you can simplify this also by this way. Okay, but what is more better recommended is that since you're having square root over here, so it is always recommended to put like t, this particular part, as t square. Now if you put this particular part as t square, then your problem will be much more simple, in terms that you'll basically get 2 dx is basically equal to 2t dt, right? Now why I am telling you to take this part, because you will understand. So over here you will have only one simplification, and your integral will be just simplified as, so this will be x is equal to t square minus 1 upon 2, and your integral becomes, and this particular integral will become t square minus 1 upon 2, right? T square minus 1 upon 2, and you will have, with this over here you will have on a t, right? And this dx, so here over here dx is basically 2 times of dt, so you will have t square dt, right? Now you see that there you are getting reading of the square root terms, right? So you don't have the square root terms, so that is basically simply for simplification for a calculation, right? So from here you can take out the solution. It is very simple. So you will half will come out, because it's a constant, integral t to the power 4 minus t square dt, right? That's what you have, and therefore you just simplify, and you know that in integral x to the power n dx, when n is not equal to minus of 1, this particular thing is equal to x to the power n plus 1 divided by n plus 1 plus some constant, right? So if you just mention this formula also side by side while you are writing your answers, it is definitely seen at a plus point, right? So therefore this will be equal to 1 by 2 times of t to the power 5 by 5 minus t cube by 3 and plus some constant, right? Now you cannot leave your answer in terms of t because your ultimate answer was in terms of x, right? So you definitely have to show t as in terms of x, right? So you know t is basically equal to, so t is basically square root of 1 plus 2x, right? So from here you will basically get 1 plus 2x whole to the power 5 by 2 divided by 5, and we have 1 by 2 in common in bracket minus 1 plus 2x whole to the power 3 by 2 divided by 3, right? And plus some constants. Okay, so this is going to be your final answer. I hope this part is clear. Please let me know in the comment section if you have any confusion. All right, is this clear? So very simplified, right? Very simple, and the way I simplified this is basically the way you actually have to do in the actual exam also, right? So if you're doing all these steps, you're definitely going to get the full marks. So this was a 2-marker problem. Okay, so person who have basically done this all the steps correctly and have mentioned everything step by step and properly, they're definitely going to fetch a +2. Okay, so this part is fairly simple and clear enough, right, to all of you? If you have any query, please keep me posted. Right, is it clear enough? Fine. All right, so with this let's move to the next problem, right? Again we have a question from definite integral, and this is another +2-marker problem. Okay, so we have another 2 marks problem. So this is a definite integral problem, but I took this problem because it's an integral problem, right? So the question says that, again, please mention that integral, let I be integral 0 to pi square by 4. Okay, let me write it clearly. It might not be visible to all of you. Yeah, so 0 to pi square by 2, that's the limits. Okay, pi square by 2 by 4, sorry, pi square by 4, that's the limit. And we have with us sine of square root of x divided by square root of x, right? Now again, looking back at the previous problem, you can understand that whenever I have a square root term, it is obviously explainable to understand that please try to get rid of the square root terms. And in order to get rid of the square root terms, the best method is basically to do substitution. So let us say we substitute square root of x as basically, or let us say we substitute x as t square. Okay, that is what is square root of x is equal to t square, right? So let us substitute x is equal to t square. So once we substitute x is equal to t square, so we'll basically have dx is basically going to be 2t dt. I hope this part is clear, right? So we will have dx is basically equal to 2t dt, and if you have this part as clear, then definitely on substituting back into the integral, we'll basically have this of the form 0 to pi by 2, 0 to pi by 2, because your limits will now change as per the new variable, right? So over here I will have sine of t, sorry, so I will have sine of t over here, sine of t by t. Now in place of dx I will put it as 2 times of t dt, right? Now the advantage of doing this, the t and t get cancelled out, and you will definitely have the answer as 2 times of integral 0 to pi by 2 sine t dt, right? Now you can definitely simplify this, and this is basically going to be equal to 2 times of minus of cos of t, and putting the limits, so you're definitely going to have the answer as, so from here you will get the answer as 2, right? So the ultimate answer of this particular integral, definite integral, is going to be equal to 2, right? So +2 marks if your answer is 2, right? So if you're solving it step by step and you're showing all the calculations, then definitely you're going to fetch the full marks, right? I hope I was clear enough. All right, so do you have any questions? Any questions? I hope this part is clear enough, right? So this is fairly simple, right? So you can just simplify this part also by yourself also, right? So you can see that the cbse questions are fairly simple. The only way is basically to fetch a good number is basically by expressions. Okay, so the better way you write, the better marks you're going to get, right? So this expression was simple and fair enough, right? Okay, so let's move to the next problem. And again, we have another problem from the CBSE 2024 paper. So you can see that all these questions are from 2024, right? So there was a lot of question that was asked from integrals. Okay, so you can just expect that integral is really an important topic to prepare for, right? Okay, so now this question is basically to be solved by partial fraction. Okay, so I took this question just because it has different method of solving the integral, right? So the question says that, let us again write it over here. Integral, the integration is given as x square upon x square plus 4 multiplied with x square plus of 9, okay, into dx, right? Now, in order to simplify this integral, what I will do, I will again use a, first of all, use substitution, okay. So I will substitute x square as some t, okay. So therefore, I will have 2x dx is basically equal to dt, right? So therefore, I can substitute back into this particular integral form. So therefore, the integral will therefore become integral. This will be a t, and instead of dt dx, we will have 2t dt, right? And then square divided by t plus 4, and over here I will have t plus 9, right? Now, if you look at this particular form, it is basically becoming 2t square divided by t plus 4 divided by t plus 9, right? Now, the best method to solve this problem is basically to assume by partial fraction, right? So let us say, so let us do it over here, partial fraction part. All right, so I hope this part is clear enough. If you have any question, please tell me. Okay, so sorry, there's a mistake. Yeah, right, correct. So here there is no 2, right? It should be dt by 2, right? Sorry, very sorry. It should be dt by 2. Extremely sorry. Okay, so please make sure that you don't do this kinds of mistake. Okay, this should be dt by 2, and there is one more x over here, right? I hope this part is simple, right? So you can understand, right? How did I make the changes? Okay. So your dt, so your dx is basically equal to dt upon 2x, okay? So over here, in place of x square, I just change the same, and then I can do this manipulation, right? So your ultimate integral will be of the form t upon t plus 4 into t plus 9, right? So therefore, what I will do over here, I will just take help of the partial fraction, okay? So I will write it over here by partial fraction. By partial fraction, I can decompose this given fraction as a upon t plus 4 plus b upon t plus 9, right? So on simplification now, what we'll get, we will basically get a is basically equal to minus 4 upon 5, and I will get b is equal to 9 upon 5, right? So I will get b is equal to 9 upon 5 and a is equal to 4 upon 5. I hope this is what you are all of you are getting, right? Right. So therefore our ultimate integral will basically have the form integration minus 4 upon 5 divided by t plus 4 dt plus integration 9 upon 5 divided by t plus 9 dt, right? Now you know that integral dx upon x is basically equal to natural log x mod of x plus c, right? So if you just remember this formula, so you can just substitute back into this equation. So we basically get 4 upon minus of 4 upon 5 minus of 4 upon 5 natural log of just a second, did I do any mistake over here? All right, yeah, it's correct. So what is also you can do is that if you just substitute this t as, if you just substitute t as x square, so therefore you will basically get this of the form tan inverse of x by 2 into 1 upon 2. So that is basically going to be over here, and plus 9 upon 5. Again, if you substitute t as x square, so again you're going to get it as tan inverse of x upon 3 into 1 upon 3. So your ultimate answer is going to be basically minus of 2 upon 5 tan inverse of x upon 2 plus 3 upon 5 tan inverse of x upon 3 plus some constant. That's going to be the correct answer of this particular problem. All right. So I hope you get the answer how I am basically calculating it. So your answer is basically going to be minus of 2 upon 5 tan inverse of x upon 2 plus 3 upon 5 tan inverse of x upon 3 plus some constant. That is going to be a final answer. So that's how you actually have to represent this in your exam also. Okay. So, and one more thing, one more beneficial topic is that, so whenever you are getting an answer, please mention that in a box. Okay. Write answer to the particular problem or answer and put it in a box. Okay. That will basically look your professionalism. Okay. So the integral is basically of this your expression. Okay. So I hope this part is clear, right? Please give me a thumbs up if you are able to understand this. If you have any query, let me know. All right. So, okay. So I hope you can see all the next question in the screen, right? So let us start with the next problem. Okay. But before I start with the next problem, I actually want all of you to please try to go through the problem. Okay. Try to understand like what are the different methods that you can apply over here to get to the final answer. What do you think? Now again, this is a question from 2024 paper. So you can see there were a lot of questions that were asked in integrals. Okay. So this is a fairly simple problem. Okay. There is not much of a difficulty associated with this. It's only about like substitutions. Okay. So if you are able to visualize this substitution very simple, then the question is just a matter of a minute, right? Now this was a plus three marker problem. Okay. So I want all of you to please look at the question, at least try to solve it by yourself. Okay. Maybe in a rough, you can definitely try to solve this problem first of all. All right. So okay. So moving further, so we have a given integral. Now this is a question which is also been asked in your JEE mains paper as well, right? So first, people who are actually preparing for your JEE main simultaneously will also definitely benefit from these lectures. Okay. Also, apart from this, we are also going to start with some JEE mains previous year problem solving questions soon. So people who haven't subscribed to this particular channel, please do consider subscribing to this particular channel. Okay. All right. So we have an integral over here, which is mentioned as 0 to pi by 4. Now given as sin x plus cos x divided by 9 plus 16 times of sine of 2x dx, right? We have this particular given integral. Okay. So the given integral is of this particular form, right? Now, an interesting part you will try to visualize this from here is that now we can write this sine 2x as 2 times of sin x cos x, right? Now, why I'm basically doing this part, you will understand that is that now you also know that sine square x plus cos square x is equal to 1, right? So therefore, 1 plus, now this is not something you are able to write in an examination, but this is just for explanation. So 1 plus sine 2x is basically equal to sine x plus cos x whole square, right? This is something that I want to remember, right? If you put in place of plus, if you put it's a minus, so it will definitely will give you sine x minus of cos x whole square, right? As simple as that, right? Now, so what I will do over here is that, so I will first of all assume this part. I will assume that sine x, so I will put sine x minus cos x as some variable t. Okay, first of all, I will put sine x minus cos x as some variable t. So now if you just differentiate this, you are definitely going to get it as sine x plus cos x. Okay, because differentiation of cos is minus of sine x, or minus plus of sine x, and in differentiation of sine x is going to be cos x. Okay, so plus cos x. So this part into dx is going to be equal to dt, right? That's the first substitution you're getting, right? Now why I'm basically doing the substitution is that, so from here, if you have this particular result, so what I can write is that, so this part 1 plus sine 2x, okay, I can easily write this as, so I have, let us write 1 minus, okay, 1 minus sine 2x is going to be equal to, so 1 minus sine 2x is going to be equal to t square, right? So therefore I will have sine 2x is basically equal to, so I will have sine 2x is basically equal to t square minus, sorry, 1 minus t square, 1 minus t square, right? Is this simple, right? 1 minus t square. So from here, proceeding further, what we can do is that now if we just replace this into this given equation, so if I just put them back, so on substitution, so I will write it over here on substitution, we get our integral basically becomes of the form 0 to, sorry, minus 1 to 0. So if you put 0, your x will be, sorry, your t will be basically minus of 1, and on putting pi by 2 you will get it is basically 0, right? So your limit in t is minus 1 to 0, and you will have dt upon, so over here it is sin x plus cos x dx, right, which is basically equal to dt, right? So dt upon, so this is going to be basically of 9 plus 16 times of 1 minus t square. So if you just simplify this, it's going to basically become minus 1 to 0 dt upon 25 minus 16 t square. Now if you just look at this particular form, it is basically very similar to this particular integration, right? A square minus x square dx, integral a square minus x square dx, right? So we can basically write this as 1 upon 2a 1 upon 2a natural log of a minus x plus divided by x plus a mod of that plus c, right? So if you just remember the formula we're applying over here, so you will have, see, what you have to do, I have to make the coefficient of t square as 1, right? So what I'll do, I'll just take 1 by 16 as common, okay? So therefore this is basically equal to 1 upon 16 integration 0 minus 1 to 0 dt upon, now this part will basically be equal to 5 by 4 whole square minus t square, right? So on simplification this is going to be basically equal to 1 upon, so I'm just putting this over here in the formula, okay? So I will get this as 1 upon 40 natural log of 5, um yeah, pardon me, sorry, that there's a small minor mistake, okay? So this is a plus and this will be minus, okay? just just a sorry, okay? So this is basically a minus x and this is going to be a plus x, okay? Just the opposite part of it, okay, fine. So from here you'll get this part as um, 5 plus 40 divided by 5 minus 40 on cancelling the common part plus c, right? But you will don't have plus c because it's a definite integral problem, right? So therefore you just need to put the limits, so you just put the limits of this particular integral from minus 1 to 0. So you just put this particular limit back into this particular equation, so you definitely get the answer as 1 upon 40 times of, now if you put 0 it is going to be natural log of 1, which is 0, right? So therefore minus of 1 by 9, so if you put minus 9 minus 1, you're definitely going to get 1 upon 9, which is basically natural log of 9, right? So 1 by 9 we just use the natural log properties, right? So there is going to be equal to minus of 9, and then minus and minus got natural log of 9, right? So as simple as that. Okay, so you can further simplify it as, so you can write 9 as 3 square, so you can take the square term out and therefore your answer will be like 1 upon 20 natural log of 3. Okay, so you definitely know that the value of natural log of 3, you can put it, or you can definitely leave your answer in this particular form. Okay, so the answer to this particular problem, is going to be equal to 20 times of natural log of 3, right? So as simple as that. Okay, I hope this part is clear. Okay, do you have any confusion? Please let me know. I hope the way I am deriving these questions are basically very simple. Okay, if you have any, if you are able to find out any mistake, please let me know. Okay, I hope the solution is clear and the answer are matching, right? Okay, so I hope you are also getting the same answer. Please confirm. Everyone, please confirm. All right, great, great. Okay, so we understand this, right? So therefore with this let's move to the next problem, and again we have a problem from your 2024 paper, right? So if you just look at this particular problem, again a very simple problem, so I actually want all of you to do this particular part, right? So it's a very simple, right? It's more than simple, right? So what you will do over here, you have an integral given 0 to pi by 2 sine of 2x into tan inverse of sine x dx, right? So what will I do? Looking at sine 2x, I know the formula of sine 2x is basically equal to 2 times of sine x cos x, right? So I know this particular formula, right? Okay, so what I will do, I will just make use of substitution. Okay, so I will put sin x as some t. Okay, so if you put sin x as some t, then on differentiating both the sides, I will have cos of x dx is basically equal to dt, right? So let us just put it back into this particular integral equation. So I will have it as integral. So in place of, like, we are putting sin x, so it will basically 0 to 1, right? That is going to be basically now form of, so this sin 2x, since we are having a sin 2x over here, so I will just split the sin 2x as 2 sin x cos x, right? So this cos x and this dx part will basically give me dt. So it's going to be 2 times of t, tan inverse of t into dt. I hope this part of substitution was simple and clear enough, right? Okay. So now the problem is very simple. It is a problem of by parts, right? So just apply the by parts. So I will just apply by parts over here. Okay. So I hope you all recall the by parts rule, right? So if we have integral of u into v dx, the by part rule says that if you consider this u as a first function and the v as a second function, so it is said that first function into integral of the second function minus differentiation of the first function with respect to x into integral of the second function into the integral of this entire thing with respect to dx, right? So that is what the by parts rule has to say, right? So if you just use this by parts rule, what we can further simplify this as 2 will be kept out of the bracket, so it's a constant. So we will get tan inverse of t with the given limit 0 to 1. So when you're putting limit, just put a small bracket over here and then just keep bigger bracket, okay, into integration of this part, so that is t squared by 2. Oh, sorry, so you just need to put it in the limit in the outside part, okay. So keep it outside 0 to 1 minus now the advantage of doing this is the second. So over here in our case, tan inverse of x is the first function and t is the second function, right? So therefore minus of, I will have it as half times of this is basically t square. Now differentiation of tan inverse of x is basically 1 plus 1 by 1 plus t square. So this is going to be a simplification, right? Dt, and the limit will be minus 0 to 1, right? So you can further simplify it as 2 times of, so we just simplify this part, it is basically 2 times of t square by 2 into tan inverse of t. We put the limit later on, minus on this part will be basically simplified as, so what we can do is like 1 plus t square minus 1, okay. So this 1 plus t square by 1 plus t square is going to be 1, so dt, so that is going to get the result t, right? So we'll have half times of t, and then minus and minus will basically become plus, so plus of 1 by t, 1 plus t square, that is going to be tan inverse, right? So we will have tan inverse of t from the limit 0 to 1, right, and half times of that. So that is going to be our final answer. So if we just simplify it further, so we are going to get it as, so if you just put the limits 0 to 1, so we're going to get this part is over here as 2 times of pi by 4 minus of 1 by 2 minus, and this part, so this is going to give me the following result, okay, that is 2 times of pi by 4 minus 1 by 2. So one further simplification, what we can write, this is we can write as pi by 2 minus of 1, okay. So that is going to be our ultimate answer. I hope this part was simplification was really simple and clear enough to all of you, right? So therefore we get the final answer as pi by 2 minus 1, okay. So this was another plus 3 marker problem, okay. So if you just do this all these proper steps correctly and you get to the answer, you're definitely going to fetch the full marks, okay. So please remember how are we doing and how actually you have to also do in the paper, okay. So this part is simple and clear enough to all of you, right? Please let me know if you have any questions. Is it simple and clear? I'm hoping that you're able to understand this. Fine. Okay, so moving further with the questions. So now we have with us some more previous year problems. So this is from the paper 2020, right? Now before we solve this particular problem, I actually wanted to tell you about a very important concept, okay, that is basically a shortcut tricks. Okay, so this is also something as a shortcut trick that you can apply, okay. For example, if you have an exponential limit e to the power x or exponential form of e to the power x into f of x plus f dash of x into dx. Okay, f dash of x into dx, and you just want to integrate it. Okay, so what I suggest is that you know that this particular form will be very simple. You know how. So what I do, I just try to express this as e to the power x and f of x dx plus e to the power x f dash of x dx. Okay, now what I suggest to all of you is that now consider this. Now consider over here this. Let us first of all try to get the result of this. Okay, now I will see that if I try to get the result of this particular integral by parts. Okay, so by using by parts, so by using just by parts, what I can get this particular result will be simple. Is basically, so here e to the power x will be second function and this is the first function, right? So this is your result will be f dash of x into e to the power x minus integral of, so okay, now all right, so do this particular. Okay, instead of considering the f dash of x as the second function, you consider this as the second function. Okay, so this is the second function and this is the first function. Okay, so therefore you will have this as e to the power x, e to the power x into f of x. Okay, so integration of f dash of x is basically going to be equal to f of x, right? So minus, now you will have differentiation of e to the power x and this is going to be f of x, right? Now what is the advantage of doing this substitution is that what we find out, the ultimate result is basically, this part is basically simplified as f of x into e to the power x minus e to the power x into f of x, and that is what is present over here. So therefore ultimately this part and this part is going to be cancelled out. So therefore the answer of this particular integral is basically going to be simplified as e to the power x into f of x plus some constant c, right? So very simple result. Okay, very simple and straightforward results. Okay, so if you just recall or remember this part for your as a shortcut for the examination, you can definitely get to the answer. Now if you just look at this particular problem, I can solve it in one line also, right? But again, if you are doing this particular shortcut, please mention that this is the step you are basically using or how you are deriving it. Okay, or if you are not, please go on to do this step by step. Okay, so over here we have integration of e to the power x into, now if you just take this x as common or you cancel out, so this is going to be natural log of x plus 1 upon x, right? So looking at the problem, what if you consider this natural log of x as function f, then 1 upon x is basically nothing but the derivative of this particular function f of x, right? So again, this is going to be out of this particular form, right? So therefore the ultimate answer to this particular problem is going to be equal to e to the power x into natural log x plus c, right? That is going to be option number D. Got it? That is going to be option number D. That is the right answer to this particular problem. Okay, now this is a one marker problem. Okay, that was asked in the cbse 2020 paper. Okay, so if you just recall this particular problem, you can definitely get to the answer in one line. Okay, so these types of problems are very crucial for your JEE mains as well. Okay, so students who are actually preparing for your JEE mains, please recall and make sure that you remember these kinds of shortcut for your exams. Okay, these are very useful and will actually help you in your like problem solving. Okay, so now you can definitely do this by actually doing the by parts and all that. Okay, I have no issue with that. You can definitely come to the answer with that part also. Okay, but this is something that I wanted to know for your shortcut. Okay, so I hope this part is clear. Please let me know, anyone. Just put a thumbs up. Just put a thumbs up if you're able to understand this. Just put a thumbs up if you're able to understand this. Okay, because that will be a motivating factor for me as well, because I have been continuing this series. Okay, so with this actually we are also working on a lot of things that are basically coming ahead of us. Okay, so there are a lot of surprises that are basically expected from our side. Okay, so please do not miss those surprises. Okay, so I definitely ask all of you to basically like as well as subscribe this content. Okay, so that you do not miss out any of these notifications. Okay, and don't forget to click the bell icon so that you can get the notification as soon as we are live. Okay, I hope you are able to understand that and get these questions clearly done, right? So with this part, let's move to the next problem. And another problem we have, this is a very nice, fantastic question we have with us. The question is basically from your CBSE 2020 paper, as well as it was also asked in 2014, right? So you can see that the questions generally do get repeated, right? Now, I actually want this particular problem to be solved by all of you, right? So I will basically give you a hint. Okay, rather not solve it entirely, but I will give you a hint. Okay, what you can do, you have a given integral from pi by 6 to pi by 3, right? So we have, now this hint is very simple. That is basically we have with us sin x plus cos x dx divided by square root of sin 2x. Now if you recall from the previous questions, some previous problems. So over here, what did we do over here? That is, we replace sine 2x as 1 minus t square, right? So therefore, what you can understand is that sine 2x is basically equal to 1 minus sine x plus cos square x whole square, right? Of that. So therefore, I'll do the same thing over here. Okay. So I will just split this. I will just split this part. Okay. And I will try to express this in terms of sine x minus cos x. Okay. Sine x minus cos x. Now you will understand like why I'm doing this, because if you assume, if you put sine x minus cos x as some variable t, therefore on differentiating this is going to be equal to sine x plus cos x dx is going to be equal to dt, right? Which is basically present in the numerator over here, right? Therefore, this particular part of the integral can be simplified as, so I'll put the limit later on. So first of all, I can write this as dt, right? This numerator part. Therefore, and square root of, now sine 2x is basically equal to 1 minus t square, right? Now, therefore, ultimately you see that this particular form will simplify to this relation, right? As simple as that, right? So you can see the what is the power of substitution over here, right? So if you know the substitution very clearly, if you know the trigonometric identities and the formulas at your fingertips, then you are definitely going to ace at this particular problem. Okay, that problem is not very difficult, it is just very simple. Okay, maybe at the first time it might look difficult to all of you, right? But while you're practicing with this particular problems, this won't be an issue anymore, right? So okay, all right, and the limits of this particular integral is going to be become, so if you put x is equal to pi by 6, it's going to be equal to root 3 minus 1 upon 2, and if you're putting s as pi by 3, it's going to be equal to root 3 root 3 minus 1 by 2, and this is going to be minus of root 3 plus 1 by 2. Okay, can you everyone please check what are we getting over here? Okay, I hope this part is simple, right? Now this is very simple. This is the integration of sine inverse of x. Okay, so we can just continue it over here, and we can definitely get to this particular integral as sine inverse of t. Okay, so your ultimate integral will be basically from sine inverse of t within the given limits. Okay, so I am leaving this calculation up to you. Okay, for the given limit, you will basically simply substitute and get to the answer. Okay, and rest is simple, right? So you will definitely get some, like this minus of alpha and plus of alpha over here. So that is what you will get. So let us consider this as alpha. You will understand, right? So if you just simplify this part, you will basically get it. Okay, so ultimately you will have the answer as, ultimately what I have got the answer is basically 2 times of sine inverse of 2 times of sine inverse of square root of 3 minus 1 by 2. That's what the answer I've got over here. So everyone, can you please check what's the answer you are getting? So everyone can check, okay, and let me know. Fine. So this part is fairly simple. I hope everyone can follow, right? If you have any query, keep me posted. Okay, fine. So okay, so I hope this part is very simple and clear enough. So remember it next time. So whenever you have an integral trigonometric functions involving trigonometry, so please don't forget to use the trigonometric identities. Okay, because the trigonometric identities will definitely make your life easy and will help you to get the answer really fast. Okay, so I'm leaving this part up to you to understand. I hope this part was clear. Okay, so I'm not writing this entire step-by-step solutions. Okay, so please make sure that you are basically writing that down when you are basically making note of it. Okay, all right. So with this, let us move to the next problem, and I have this problem basically as a homework problem to all of you. Okay, now this is a very interesting problem. You will understand that it also makes use of trigonometric identities. Okay, so I will again write it over here. Yes, trigonometric identities. Okay, so you see that integrals involving trigonometric identities basically is all about how well are you with the identities. Okay, so if you are able to manipulate the identities well and now, so therefore definitely you can get to the answer. Okay, what I will suggest is that over here you just take this cot as cos by sine, right? So this square root of cos by sine, so therefore you can get this integral of the form pi by 6 to pi by 3 pi by 6 to pi by 3, and this part will basically be equal to square root of sin x divided by square root of sin x plus square root of cos x. Okay, now you have one very interesting and important relation, that is a to b f of x dx should be equal to a to b f of a plus b minus x dx. Okay, so this is what you will basically get the result. So if you just apply it over here, you're definitely going to get the result as pi upon 4. Okay, so I'm leaving the part up to you. Okay, so please try to check this part and you can get with the answer. Okay, so we'll have 2 times. So if you just take this part form, so you can also write this particular integral as square root of cos x divided by this same part, right? So you just add it, it is going to be equal to 1. So ultimately you have pi by, so pi by 3 minus pi by 6 is going to be pi by 6. So 2 times of the integral is going to be pi by 6. So ultimate answer is going to be pi by 4. Sorry, pi by 12. Okay, so ultimate answer is going to be pi upon 12. So I hope everyone do copy from here. Okay, so this part is fairly simple. I'm expecting all of you must have understood this. Okay, so this was all about today's lecture on, and one more homework problem for all of you. Now this is also to be used by the use of properties. Okay, so please use the trigonometry, the properties of definite integral. Okay, so please use the definite integral properties. We've already seen that in the previous lectures of applications of integrals. Okay, so please make sure that you basically understand these problems and you can come up with the answers. Okay, so I will be basically waiting for your answers in the comment sections. Okay, so if you're getting the answer, please let me know in the comments. I will be very happy to answer to all of your queries. Okay, so from here let us end our session. Okay, I hope we had a fruitful discussion discussing about all these important notes about integrals, right? So please remember this integral note as well as this part, right? This is going to be making your life pretty much easy. So you can see that in today's lecture our more focus was primarily on substitution, right? So in upcoming lectures we will also have one or two more integral sessions where we basically focus on the part of properties of definite integrals, and maybe in one part we can also focus on more on the properties of like by parts or applications of derivative or the reduction formulas. Okay, all those things. Okay, so you can expect that we can have one or two more sessions where we discuss about other previous year problems. Okay, so with this I hope that your entire preparations of cbse examinations is going to be very simple and clear enough with this particular lectures. Okay, so please don't forget to subscribe to this particular channel because we are working very hard for this to help you out with your contents. Okay, so this is all for your, and it's all available just for free, right? So please make sure of this free contents at your best. Okay, and if you like this video, please don't forget to leave a like and do comment me with the answers that you're actually having. Okay, if you are having any suggestions, please do post in the comment sections. Okay, so I will be looking forward for your comments. Okay, and please don't forget to subscribe and hit the like button. That's it, right? So with this, let us end our